So now that we've described the functional purpose or the goals of our system and the abstract function or the balances of our system, we now want to get into the generalized functions or the processes of our system. So the generalized functions explain how the causal laws at the abstract level are achieved. So I think about these as processes, I think about these as action words. So they are words like running, jumping, stopping, also TION words like evaluation, combustion, adaptation, anything where it's how the system acts in order to do the things in compliance with the balances or the abstract functions in order to achieve the goals or the functional purposes. Again, some examples of these on the transformation side, we have words like combustion, convection, conduction, radiation, evaporation, condensation, fission, fusion, distillation, cracking, and then on the less sciencey side, moving, launching, digestion, learning, forgetting, discounting, selling, buying, all those things for transformation. With homeostasis, we have things like respiration, reorganization, maybe even diffusion. So as we look at the car, if we dig just into the conservation of energy and energy flow, we find that there's quite a few things that have to happen at the process level. You have fuel injection, combustion. Now this isn't an ing or a TION word, but it's mechanical work. This is my action word. Heat loss, I guess you could call that losing or gaining, but heat loss is probably a better way to say it. And that's through gas exhaustion and through cooling. Those are some of the examples of how that works in a car. So looking at that same car, you can actually take a more detailed look at the abstract function layer, and that's this one, and then start to tie those one to one or one to many down here to all of the processes. So in order to have a chemical energy source, you have to store that energy or that fuel, so that could be storing. In order to transfer energy, you must do fuel injection if that's for a combustion car. In order for that energy conversion, you're going to perform combustion. Energy transfer, you're going to do mechanical work. And because we know there are energy sinks in there, these are the two processes that are the major contributor to energy sinks in the car. So one of the big confusions at this level, and it's just a wording problem, is processes versus tasks, especially if you've done quite a bit of process mapping or process improvement in your past. What you're probably doing is not the same kind of processes we're talking about here. What we would consider those are usually more task-oriented. So with the processes, these are the activities happening in the system that the operator is monitoring. So there are these activities in the system that enable those balances that are required in the system. So they usually don't, they don't include the tasks. So it's not things like, first monitor this system, second, my second task of the day is to double check on this other thing, my third is to detect a problem. So it's not the tasks involved. It's not it's not the tasks to build the car. It's actually what the car is doing. Now, if we're actually trying to monitor the process of monitoring, then yes, all those things would still be in there. Let's continue on with our Ohio State example, now getting down to the generalized function or the process level. So again, as we look at abstract function, as we want to increase the graduation rate, how do we do that? There's a bunch of things we can do. One of the things is we can promote learning. We can be doing learning. Now, exactly what that is, different folks say different things, but we definitely want learning to be taking place in the system. The other thing we need to have to increase that graduation rate is instruction. So we want both sides of that. We want instructors instructing. We want students learning. We also, in order to know, midway through if these students are going to graduate or not, we need to do some kind of evaluation. So we could also call that assessment, but we'll call it evaluation for now. As we're talking about increasing the caliber of incoming students, in order to do that, we need to do recruiting. We also need to do evaluation of some sort, different kinds of evaluation, but still evaluation. As we want to increase the caliber of faculty, we want to do recruiting, we want to do evaluation. And one of those things that really does help bring faculties in is actually paying them a salary. So we want to paying. And the other thing that how we conserve time and resources is we have to factor that into the paying as well. So those are some of the things that will come into now increasing research awards or other things that we can be doing in those things. But I think this is again a nice example of how the processes work out in a larger scale system.